Our next section uses the term magnitude, which I've probably already referenced. It just means the length of the vector that we're looking at. To find the magnitude, basically we're using the distance formula, the magnitude of vector v. If it's using the numbers a comma b, we use this terminology, or this symbolism right here. It's like absolute value around the name of the vector, but really it just means magnitude in this chapter. It's not going to equal a squared plus b squared. It's going to equal the square root of a squared plus b squared. It's basically using distance formula or kind of Pythagorean theorem to figure that out. So in our opening example, we want to find the magnitude of vector 3 comma 4. Just to show you a very quick picture, we'll leave the square root symbol up there for right now. But if this was the vector 3 comma 4, 3 to the right, 4 up, if I were to put in like I guess red sides here to represent the side of 3, the side of 4, I create a right triangle. And so a squared plus b squared should equal the hypotenuse squared. And if I don't want to have hypotenuse squared, if I just want to solve for that, I would have to take the square root of a squared plus b squared. So that's where this formula kind of comes from. Pretty simple to find the magnitude then of vector v. Mathematically, the symbolism is absolute value around a v, and it's just going to be the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16. Okay, that just equals the square root of 25, which is 5. Now, many of our questions that we look at probably won't have this nice number that we get in the end. It's okay to leave your magnitude as a square root. If I could have left it as square root of 25, and that would be perfectly acceptable for most of our homework sort of questions. So do be expecting some messy numbers, I suppose, in these kind of questions. Okay, from there, we can now find something called a unit vector. So typically vectors can vary in distance and direction. A unit vector has to have a length of 1. We call it a unit vector because the unit circle has a length of 1. So if we want to find a unit vector based off of a given vector, we simply divide the given vector by its magnitude. So again, we're going to use 3 comma 4, and if we were to move on here to part F, if I want to find a unit vector that goes in the same direction as the vector 3 comma 4, I simply divide 3 comma 4 by its magnitude. So a lot of times instead of instead of dividing, we might write it initially as 1 over 5, there we go, times the vector 3 comma 4. So instead of dividing, I'm kind of multiplying by the reciprocal. It means the same thing, and now I can use my scalar multiplication idea of distributing. Maybe it just makes a little bit more sense mathematically, I don't know. But if I distribute that 1/5, I get 3/5 comma 4/5, which you could also write as 0.6 comma 0.8. So that's kind of the mathy side of it. I do think it's good just to get a quick visual of what that looks like. So let's go to Sketchpad a second. Let's get my cursor first. Okay, go to Sketchpad, and for a unit vector, okay, here is the vector 3 comma 4. If I were to kind of put a unit circle in there, so you can see it goes to the right 1, up 1, left 1, down 1. I'm basically looking for the coordinates right there because that's going to give me a length of 1. It falls on the unit circle, and it just happens to be where the vector and the unit circle cross. So I can calculate those here. It does end up being 0.6 comma 0.8, which is what we found in our notes. So we can use unit vectors for a variety of things. I think at this point I'm going to stop here, and we'll pick up with some more complicated stuff in our next video.